Hey, what's up guys? Welcome back to another machine learning video. In this video, I'm going to teach you how to encode categorical data in your dataset. This is another step in pre-processing your dataset for machine learning. Last time we learned about data cleaning, and next time we'll learn about feature scaling. So what is categorical data? Categorical data is data in the form of labels rather than numbers, and those labels represent distinct groups or categories. So up to this point, we've worked with data in the form of like numbers, numerical data, but you may have also seen in a column, for example, in a data set, string data, not just any random string, but different types of string. So like a color, red, blue, green, black, etc. Categorical data is in the form of a string usually, but it can't be any string. They're distinct strings that can be chosen from. So what we're going to be learning about, like I said, is encoding the categorical data, which simply means to convert it to a numerical representation, because that's how machine learning models like to work. They like to work with numbers usually. So there's two different types of categorical data. There's nominal and ordinal. Nominal data is when there's no order. So for example, gender is just male or female. A male is not above a female, or a female is not above a male. There's no order in these two options here. Same thing for color. You have red, blue, green, and black. It doesn't really make sense for black to be better than green or green to be better than red or any of that. They're just different options that you can choose from. So any type of categorical data that is not ordered in any way is nominal. But then you have ordinal data, which is, like the name implies, ordered. So you have something like the size, for example, small, medium, large, XL, XXXX, XL. As you can see here, there's an order that's implied. So medium is bigger than small, XL is bigger than small, bigger than large. You get the point. Another example is ratings. So if you have a data set that has ratings in it, a ratings column, and you have these different options here, there's very clearly a hierarchy for these different options here. So poor, okay, average, good, excellent. Obviously, excellent's better than poor, so there is a order to these options here. And that's literally it. So that's the difference between the two different types of categorical data, nominal and ordinal. Ordinal data is ordered in some way. So let's start with the ordinal data. How can we encode it? Meaning to translate it into numerical data. So here we have a little data set. So we have color, size, and IQ. As you can see here, we have very clearly a categorical feature for color. So this is red, blue, green, and you can clearly see that this is also nominal, meaning that there's no particular order. We also have size, which is a ordinal categorical feature because there is an order. So small, medium, large, and then medium. And then you also have IQ, which is just regular numerical data. I just wanted to throw that in there. So 120, 67, 999, and 1. That is not categorical, that's numerical. So whenever you have an ordinal column or feature or data, whatever you want to call it, the simple way to encode that as numerical data is to give every unique label a unique number. So since we like to do our machine learning in Python, this is how you would represent that as a Python dictionary, or a map in other words. So you're saying that small is 1, medium is 2, large is 3, and XL is 4. So all these different options here that we have for the size feature, we have mapped into a number. You can also see that we're ordering it in the proper way because, of course, small is the smallest one, so we'll give it 1, medium is 2, large is 3, XL is 4. So the order here is very important. It doesn't really matter that it starts at 1, for example, for small, and then ends at 4. What really matters is that the numbers are descending or ascending based on the order of these options that we have here. So the order of this mapping that we have here should reflect the actual order for these options that we have. So I think this is pretty simple to understand. So every single option for every single row for size that we have inside of this data set here, we simply, use this dictionary to see what number it corresponds to, and then we get this new data set now where every single size has been replaced with a number. So small is 1, medium is 2, large is 3, medium is 2. That's literally it. So that's a really simple way that you can encode ordinal data, ordinal categorical data. Now let's talk about encoding nominal data, which is non-ordered data. Now you may think you could do the same exact thing. So for this color column here, this is our nominal data. We have red, blue, and green. Those are our three options. So we could maybe come up with a dictionary or a map that does the same thing. So red is 1, blue is 2, and green is 3. And then you get this here. So you get 1, 2, 3, 1. But this is actually a bad approach. We don't want to do this because what we have done here is we've created this mapping here that gives every single label a unique value, which is great. Now it's numerical, but now we've introduced an order into our data set. If you were to take this data set and feed it into a machine learning model, it would interpret blue as being, perhaps more important than red, or green being more important than blue. However you want to think about that. The point is that because we're ranking it in this particular way, we're implying an order when there's not an order, clearly. Green and blue don't have any intrinsic, value over one another. They're both just colors that we want to have in our data set. So this is a common mistake when encoding nominal data within a data set, and you want to avoid this approach because you're going to be encoding your nominal data as ordinal data and there's no order, so just don't do that, okay? So the approach that we're going to do instead is something called one-hot encoding. So the way that it works is we take our nominal data column and we split it up into however many options there are. In this case, we have red, blue, and green, so there's 3 different options. So now we have 3 columns, red, blue, and green, and depending on what the current, value is, we're going to have 1 or 0 for these 3 columns here. So for example, for the first one, red, right? Since red is the selected option, so in the red column, red will be 1, blue will be 0, and green will be 0. So for the second one, we have blue, so red is going to be 0, blue is going to be 1 because it's true, and then green is going to be 0, green is going to be 0, 0, 1, and then finally red again is going to be 1, 0, 0. So it may look a little weird, but I think it makes perfect sense, right? Now when we're reading this table, it's pretty easy to determine which color that we have selected currently. So if red is 1, then the other ones are obviously going to be false. It all just depends on which column here has the 1 within it. So in this case, for the first one, red is 1, the others have 0, so it's going to be red. And now with that, we have a way of representing the color without implying an ordinal relationship. Just to recap, we simply took the feature column that is nominal, and we split it up into however many columns there are, depending on how many distinct labels there are. So if there's 3 distinct labels here, red, blue, and green, we're going to add 3 new columns for red, blue, and green, and then whichever one is selected for that row will have the 1 for that column, okay? So the only downside to this approach of one-hot encoding for encoding nominal data is that you introduce something called multi-collinearity, and all that means is that the columns that you have added are going to rely on one another in a linear way. Without diving too deep into it, basically when you take this color and split it up into 3 different columns, you now have 3 columns that are highly correlated because they sort of work together to represent a color. So with that said, an easy way to help prevent against this whenever you're doing one-hot encoding is to drop one of the columns. In this case, if we were to drop the red column and just have blue and green, you may be wondering, how do I know what color it is? And it's actually pretty simple. So if we just read this first row here, if blue and green are both 0, this implies that red would be 1. So we know that it's red. So we can just pretend by putting a 1 here. So for the second one, blue is 1 and green is 0, so we obviously know that's going to be blue. And then for the third one, blue is 0, green is 1, so we know that's going to be green. And then for the last one, again, blue is 0 and green is 0, so it's going to be red. So even though we've dropped the red column completely from our data set, we are still able to correctly determine the color, and therefore we are helping to prevent against multi-collinearity, because now we don't have 3 columns that are highly correlated with one another. So that's how you can encode nominal data within a data set for machine learning. That's just only one technique, which is called one-hot encoding. There are other techniques called binary encoding that we'll learn about in the future. But this is a very popular approach that many people use, and it's a good place to start with, okay? Alright, so with all that said, that's categorical data, that's what it is. So you have ordinal and nominal categorical data, and that's how you encode it to make it a numerical representation, okay? So now let's jump into our code to see how we can actually do it with code. Okie dokie, so let's start by importing pandas, just like we always want to do. Import pandas as PD. Let's also go ahead and import numpy as np. And now we just want to import our dataset. And instead of just choosing a dataset and importing it, we're going to create a synthetic dataset, a fake one that we're just making up here. So that will do that for us. This is still using a pandas data frame, so there's no difference. It's just a little bit easier to work with since we don't have to import all that stuff. And let's go ahead and visualize it. So we'll do dataset.head. Let's go ahead and run all this code now. So this is what the head of our dataset looks like. We have a color, a size, a value, and a class. You can see that we have 3 categorical data columns here. So we have color, which is nominal because there's no order to a color in my opinion. You have size, which is ordinal because there is an order to a size. You have value, which is just a regular numerical. And then you have class, which is something that you'll see whenever you're doing something like classification, machine learning. So this could actually be our target column here. So for class, we have class 1, class 2, and class 3. There's not really a particular order in this case, so you can consider this one nominal as well. Another way that you can get more information about the dataset is by doing dataset.info, and this will tell you the data types of the columns that you have. So we have color, size, value, and class. You can see that the D type is basically the data type of the column. So we have object. This is because you have these basically string types here. And then you have float 64, which is a float is a number, as you know. So that lines up with our numerical column that we have here. And then finally we have object again because we have another categorical column on the end. Okay. So that's just another way you can sort of see what type of data that you have, which is very helpful. So let's go ahead and start with handling ordinal features. So this will be ordinal feature encoding. All right. So an ordinal feature, again, is just a categorical data that has order to it. So in this case, it would be this column here for size. You have small, medium, large, XL, okay? So we want to figure out how to map that into numerical values, but also maintain the order because the order is important for our data set. Something really helpful that you can do is by first getting all the unique values of this column. So data set, we can say size, and then we could do dot unique. So if we run this, this will give us all the unique values of our size column. So medium, large, XL, and small. And now we want to go and create a mapping for encoding. So we can do something like size underscore mapping. And we can create a new dictionary in Python, which is otherwise known as a map, by doing opening curly and closing brackets. So we can start with, we can start with XL, we can start with small, either direction is fine. Let's start with small, and we can say small is mapped to 1. We can say medium is mapped to 2. We can say large is mapped to 3, and then we could say XL is mapped to 4. Now the actual numbers do not matter. What matters is that there is an order, like I said before. So it could be 1, it could be 4, it could be like counting down, it could be counting up, it doesn't matter. So as long as there's an order, so small is 1, medium is 2, large is 3, and XL is 4, that's what really matters, okay? So now each of the labels that we have for the size column can be mapped to a particular number. Let's go ahead and apply that map by doing data set target the size column again is equal to data set size dot map, and then you pass in the size mapping, and it's literally that simple, just using pandas. So now if we go ahead and run this, and we can go ahead and print this out after, so we'll do data set dot head. Let's take a look at what we got. There we go. So we get color, now we have size, but you can see that size before was, these string values here for the categorical data. Now it's been replaced with numbers. So you can see that the first one is medium, so that should be, according to our mapping, 2, and that's exactly right. So we get 2, we get large, 3, 4 XL, 1 is small. Looks like it worked perfectly. So that is how you can encode ordinal features using pandas. Another useful piece of code here is that sometimes you may want to go backwards. You want to inverse the mapping. So you want to convert the numerical values back into the actual labels. And you could do that by doing this piece of code here. So we're creating a inverse size mapping. It's just simply doing the same thing that we did above when we defined our dictionary, but in reverse. So it'll be 1, S, 2, M, and so on, okay? So then we can apply that in the same way that we applied it up here. And now when we run this, the head, we get everything same as before. So we just simply undid what we did before, okay? So just like always, there's multiple ways to do things. Now, we just did our ordinal encoding using pandas, right? But you can also do it using sklearn. So we can do from sklearn.preprocessing import ordinal encoder. So as the name implies, you're going to encode ordinal values using sklearn or scikit-learn. So now we can go and create our encoder. So encoder is equal to ordinal encoder. And there's different parameters that you could provide to this. One of them, though, is called categories. And this is where you can define the actual order of the categories that you're trying to encode. Because if you don't specify the order of the labels for the column that you're trying to encode, it will try and figure out an order on its own. I believe it does alphabetical order, and in this case that would not work because this is not, the order of this is not necessarily alphabetical. So you have S, M, L, XL, that doesn't really make sense. So we want to specify the order ourselves, and an easy way to do that is just to do, for example, custom underscore order, and then you just got to do a multi-dimensional array, and inside of the second one you do the order. So S, you could do M, you could do L, and then XL for just however many labels you have for that particular column that you're targeting. And of course, also if there's multiple columns, then you would just simply copy this and you would have another array inside of here. That's why it's multi-dimensional. Like that, okay? And then now we can provide our custom order to our encoder. And now we want to go ahead and use this encoder to actually map the size labels into actual numbers. Since we're using sklearn, I want to do it using NumPy. So we're going to get our X and Y. Let's go back up to the top here. So let's go ahead and create our X up here. So X matrix is equal to dataset.iloc. We want all rows, and then every single column except for the last one. So colon -1, and then dot values to get it as a NumPy matrix. And then Y is equal to dataset.iloc, all rows, but this time we only want the last column, so -1 dot values. That will be a vector. So now we can come back to the bottom here, and now we only want to encode the size column, right? So within X, let's just go ahead and start by printing out X so we can visualize it a little bit better. We don't have it yet. We need to rerun this piece of code here. Now let's go ahead and run it. Okay, so here's X. This is what it looks like. It's a multi-dimensional NumPy array. We want to target the second column, right, which has our sizes in it that we want to encode. So to do that, we can do X. And now we want to specify all rows for the first one. And then after the comma, you specify the column that you're trying to target. So we only want the second column, right? So we're going to do 1. And now we can do encoder dot fit transform. I taught you about fit and transform last time, but basically the way that Sklearn likes to work is you first fit it and then you transform the actual data using that fit. In this case, we're combining both those steps by fitting and transforming it at the same time. So now we need to provide the data that we're trying to transform, right? So we're going to do X again, same as before. So we're targeting only the second column, which is the first index. And then now it wants it as a 2D NumPy matrix, right? But when we target one specific column, that's going to be a vector. So we just need to reshape it into a matrix. So that's how you can do that with reshape and then -1 and 1. So now it will actually do the fit and transformation, but when it provides it back, it's still going to be a matrix. So we want to go in and do ravel to change it back into a vector, because this is again targeting one specific column. So that will set that properly. And then afterwards, let's just go ahead and print out the values in that column so we can verify that the change was made successfully. So now we get our array printed out, our vector. We can see that as 1, 2, 3, 0, 1, 2, 3, 0, 1. So obviously this is correct in the sense that it mapped our categorical data into numerical data, but let's actually try and verify it to see if it's correct or not. You can see 1, 2, 3, so you can see that the order is increasing. So let's go ahead and verify that. So we have medium, large, and XL, and small. So 1, 2, 3, 0, that makes actually perfect sense. So if small is the smallest one, that's going to be 0, and then medium, large, XL. So you can see that it actually did the mapping correctly, which is awesome. And if we want to, just like before, we can actually inverse the mapping. So we're going to do the first column again. So first column is equal to encoder.inverse transform. And we could just copy the rest of this because it's the exact same, like that. And then we'll print out the column again. There we go. And look at that. So we get medium, large, XL, small, medium, large, XL, small, medium. So it actually is working again perfectly. So just as a quick little recap, we're just using a Sklearn ordinal encoder. We're telling it what the order is. So we're saying custom order. We're saying small, medium, large, XL, and then it's going to handle actually, deciding what the numbers are and how to do all that. So we're passing that custom order into our ordinal encoder as the categories parameter. And then we're doing encoder.fit transform. We're passing in the column that we're trying to apply this encoding to. We're reshaping it to be a matrix, because when we target one specific column, it's going to be a vector. So we're reshaping that to a matrix. And then once it's done transforming it, it's going to be passed back as a matrix. So we want to ravel it back to a vector, and then we're going to set it back on that column, okay? And so now you should know how to encode ordinal data using both data frames, using a mapping here, and also using Sklearn or scikit-learn using the ordinal encoder. So now let's talk about encoding nominal data, which is again data that has no order to it, but it is categorical. So just like before, I'll show you guys how to do it using Pandas first of all. So it's actually kind of easy. So we can do dataset is equal to new dataset dot get dummies. So what this will do is, remember, we're doing one-hot coding for encoding nominal data, because we don't want to, if we were to do it how we did it above, where we just map it one-to-one, then we would basically make our nominal data ordinal data, which we don't want to do, right? So we want to do a one-hot encoding, and to do one-hot encoding with Pandas, you can do the get dummies function. And let's just go and change this from dataset to PD. You're doing it from Pandas directly, so pandas.getDummies, and then you want to pass in the dataset like that. And now you want to tell it what columns you're trying to do the one-hot encoding for. So we're going to do color, because if we scroll up to the top here, we can see that color is our nominal data column. So we have green, red, blue, or red, blue, green. Those are the three options that we have, and we want to make it so that we have a red column, a blue column, and a green column, okay? So this should do this automatically for us, literally just that one line of code. And now after that, we'll do dataset.head to see what it looks like. So let's go and run it, see what happens. Oh, I made another mistake. This has to be equals. So you're saying the columns parameter is going to be equal to this value here, which is just the array of column names that you're trying to target. So let's try it again. And here we go. So now we have our same data set as before, except now we have a color blue, color green, and color red column for each of the different options for that original column. So we still have our size, value, and class columns, but now we just have those columns added on to the end, right? So yeah, there we go. So we can see that the first one we know was green. If we scroll up to the top again, we can see that we have green for the first one and then red for the second one. And that looks about right. So it says green, the others are false, and then for the second one, false, false, and then true, because the second one is red. So that's how you can do one-hot encoding using a Pandas data frame. But in my opinion, I think it's easier and a little more flexible if you use the scikit-learn version of this, which is the one hot encoder. So let's go ahead and make a new code block here, and I'm going to do from sklearn dot preprocessing import one hot encoder. Now the way that this one works is it's very similar to the last one where we have our fit transform function or method, and it's pretty much the exact same except for one little thing, which you'll see in just a second here. So what we want to do is, instead of putting it back into that one column, replacing the original color column with the three new columns, of course there is no longer just one column. You have three new columns, so just replacing that one doesn't make sense. That might be a little confusing, but what I'm saying here is that we want to make a variable here that will hold our three new columns, and then afterwards we can drop the original column from the original dataset, the color column, and replace it with these three new columns, okay? So we're going to do encoded colors is equal to encoder dot fit transform, same function as before. Now we're going to tell it what column we're trying to transform our data based on. So this would be our color column. So this would be the first column. So we're going to do X. We want all rows, but we want the first column. So we're going to do 0. And just like before, this is targeting a specific column, so it's going to be a vector, so we want to reshape it to a matrix. So we're going to do -1 and 1 to reshape it. And then afterwards, instead of doing ravel to change it from a matrix to a vector, we don't want to do ravel, we want to do toArray, which would essentially do something very similar. The difference here is that fit transform in this context with the one hot encoder returns something called a sparse matrix, which is just a matrix that has a bunch of zeros in it. It's a little more efficient. Basically, long story short, we just want to take that sparse matrix and convert it back into a regular matrix using toArray. So this will convert it back to a numpy array with the actual matrix values, okay? So we don't want it to be a vector. That's what ravel does. Ravel will convert it to a vector, right? But since we're not replacing a single column, we're producing three new columns, we want it as a matrix, right? A matrix is something that has multiple columns in it, or multiple vectors. You can think of it that way as well. So now with that said, what this will do, take the color column, reshape it to a matrix, fit and transform to do the one hot encoding on that column, and then it produces a sparse matrix that we then convert into a regular numpy matrix that has the three columns that we just produced from that original column, okay? So now this variable will hold that. So what we can do now is drop the old color column from the data. So we can do that by doing X, so just replace all of X is equal to X, and then we just want to target every single column and every single row except for the last, or for the first one, right? Because the first one is the color one, right? Let's go back to the top. Yeah, so the first one is color, so we just want to ignore that one essentially. So we're going to do all rows, comma, and then to skip the first column, we want to do 1, colon, and then that will go all the way to the end automatically. Alright, so now that we have the matrix with the three new columns, along with our original data with the color column dropped, we can now merge them together to create a new X, essentially. So now we're going to do X is equal to numpy, or np, dot concatenate. So we're just going to add it together, concatenate. Alright, so now we just need to tell it what two things we're trying to concatenate. So we're going to pass in inside of these parentheses here, we're going to pass in the encoded colors one first, because we want that to be at the beginning since color was at the beginning, although it doesn't really truly matter, and then X. So that will literally combine these two matrices together to essentially give you a new matrix that has all of the rows combined together from both of those matrices, okay? But you also want to add into here axis 1, which will just target the columns of the matrices, okay? That's all that will do. And then finally at the end, we're just going to print out X so we can see what this looks like, all right? So yeah, I know this was a lot, but let's just go ahead and try running it and see what happens. And here we go, here's our NumPy matrix. So we can see that we have our two original columns right here on the end. So this would be for the, what was it? Let me go back up to the top. This would be for the size and the value columns, right? But now color has been replaced with these three new columns. So this one, and this one, that corresponds to the color. So again, using one hot encoding, we take that original column and then split it up into however many unique values there are for that categorical feature. So in this case, we only had red, blue, and green, so that would be three new columns. If there was red, blue, green, and like yellow, there'd be four new columns, and so on, okay? So it's working, as you can see, which is pretty awesome. We have now successfully done one hot encoding using the sklearn one-hot encoder. Pretty cool. Something else that we can do, since we learned about multi-collinearity, is again, when you do one-hot encoding, the new columns that you create will have a lot of correlation with one another. So one easy little trick that you can do to help prevent against multi-collinearity is to drop the first column. And the easy way to do that using the one-hot encoder is just to do drop and then first. As you can imagine, that will just simply tell it to drop the first column when we do this. So yeah, let me go ahead and rerun this at the top here so we can get the data fresh. Let's run this again. And look at that. So now we only have 2 columns ahead of our size column. So you can see that instead of 3, it was 2 just because it's dropping the first column, okay? But because only one of them will be 1 or true, the other one doesn't need to be present. You can still figure out which one is the actual color, even if one of them is dropped, all right? So now we have learned about ordinal encoding, nominal encoding for categorical data, but as you can see here, if we scroll up to the very top here, we still have one column that we have not encoded into numerical data. And we need to do that because, again, our machine learning models require usually numerical data. And this would be the target column that we have here for the class. So we can imagine that we would use this data set for maybe a classification model. So just by looking at it, you can see that it's nominal data. There is no as far as we know, at least, there's no ordinal relation between these different options here. There's not an order, so we just have class 1, class 2, and class 3. So in that case, you may say, okay, maybe I can just go ahead and use one-hot encoding for that because it's nominal, right? I can just create 3 new columns for that. But because it's the target value, it's the thing that we're trying to predict, you don't have to worry about converting it to ordinal accidentally, essentially. So what we can do in this case is actually use a different encoder provided by scikit-learn called the label encoder. So we could do from sklearn.preprocessing import label encoder. We're going to go ahead and create a new instance of that. So encoder is equal to label encoder. We're going to do y, which is our target variable or vector, and we can do encoder.fit transform, pass in y again. For this one, it's okay to pass in a vector for the label encoder, okay? So we don't have to do the reshaping or anything. So yeah, we're going to pass it in, it's going to fit and transform it, and it should hopefully convert each of those class labels that we have here into numbers, all right? So let's see what that looks like. There we go. So we get a new vector with 1, 0, 1. So that corresponds to class 2, class 1, class 2. And then I'm assuming class 3 is 2. And yes, it is. So 2, 0, 1, 0, 2, 1. Okay, so it works perfectly. So what we have done here is converted each of those class labels for that last column into numbers. And again, this is nominal data because there's no order to it, but we don't have to do something like a one-hot encoding, for example. We don't have to worry about there being an order when we convert it to numbers, just because it's the target variable or the class label, okay? So in this specific situation, it's okay to use the label encoder to just directly convert it into a number to map it, okay? Alright, so that's how you can do nominal encoding, ordinal encoding, and then also label encoding, specifically for the label so that you can, convert it to numerical data. Now I'm going to show you guys one more thing, which is the column transformer, which you can use to essentially do it all at once, at least make it a little more syntactically nicer to look at. You can combine it all into one little thing. So we still have everything at the top where we import our fake little data set here. We split it into our X matrix and our target variable vector. And then down here, let's go ahead and import from sklearn.compose, import column transformer. And we've already done this above, but let's go ahead and also re-import our encoders just so I can show you what that will actually look like. Have it all together. Alright, so here we got everything that we need for this. So let me go ahead and write this code here, and then I'll explain what it does after. I think as I'm writing it, it'll become clear what it's doing. So we're going to make a new column transformer. CT is equal to column transformer. Open that up. We're going to pass in a transformers parameter. This is going to be an array. And now we just want to give it essentially a list of transformers. So the first transformer that we're going to do is going to be to transform our first column, our color column, using one-hot encoding. So this will be the one-hot column, and then the encoder we're using for that is the one-hot encoder. And then now we tell it what columns we're trying to do this on. So we're going to do column 0, which is the first column, so comma, and then we're going to add another one, the ordinal one. We're going to say ordinal encoder, create a new instance of that. And this is going to be for, just like before, our size column. So for the second column here, we're trying to convert that one using ordinal encoder. So for this one, just like before, we want to pass in the categories. So this is our order that we're specifying for it. So let me steal that from above. Now we're going to pass in categories is equal to that array. And then after that, again, we're going to tell it what columns we're specifying here that the ordinal encoder is going to work on. It's going to be the second column, or index 1. And that's it. Those are the encoders that we're going to use for our data. So after that, we're now going to specify another option, which is remainder. We're going to say remainder pass through. Okay, so what this is doing is basically combining all of our code that we did above so that we can essentially do our encoding all in one place. So we're telling it that we're trying to do the one hot encoder on column 0. We're also going to do the ordinal encoder on column 1. And then all remainder is saying is that any column that is not specified here will be ignored. So this is a list of transformers. So these are the transformations that we're doing on our columns. And then for each of these transformers, we're first just going to give it a name. We just called it one hot, but it doesn't have to be called that. That's just what I want to call it because that's what it's doing. Then we specify the encoder that we're doing on the column, and then the actual column that we're targeting. Same thing for here, ordinal encoder, and then 1. So that's pretty cool, right? So let's go ahead and try this out. So we're going to do x is equal to ct column transformer dot fit underscore transform. And then we're going to pass in the data that we're trying to transform, which is our X matrix. So this will automatically take our X matrix, do all the transformations on it for the columns that we specified, and then give us a new matrix with the new data, and then we're going to set it back onto the X variable, okay? So let's go ahead and do that, and then print out X. Let me make sure to go up to the top here and just reset the data so that it's all fresh. Let me come back down. Let's run it again. And there we go. So now we get our new matrix here. So you can see that we have our one hot encoding has been done. So we have these 3 new columns in the beginning. Then we have our size column, which has been encoded using the ordinal encoder. And then we have our regular value column, just the regular number column that we haven't touched, okay, because of pass-through. So there you go. That's how you can use the column transformer with scikit-learn. It's pretty useful just to combine everything together. It makes it way easier to work with these encoders and stuff like that, okay? So yeah, use that if you want to. And that's pretty much it for this video, guys. That's how you can encode categorical data for your machine learning data sets. Now we know how to clean our data. Now we know how to encode our categorical data. The last thing that we're going to learn about for pre-processing is going to be feature scaling, so stay tuned for that. And thanks for watching, everybody. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.